Okay, so we're going to start out lesson 8.4 with an assignment. And this assignment's a really fun activity to get you thinking about connecting the unit circle to some real life examples. And I really encourage you to somehow do this as a collaboration. So if you know someone else that's in the course, maybe you could FaceTime them or Google Hangout with them and work on this together. That would be really helpful to talk it over with people. I'm going to have this video that goes through and basically tells you how to do it. That this should be an activity where you are discovering some things that will really help you later on. So every question that you are asked, I really want you to pause the video and think about it and try it on your own before you just write down the answer that I give you. So if you keep that in mind, let's move forward with the activity. So this represents a Ferris wheel, and I don't know about you, but I'm kind of a theme park junkie. I love roller coasters and any kind of a thrilling ride. It's just super fun. So it's something that I look forward to. I love to at least visit one amusement park during the summer. So Ferris wheels, though, they're not my favorite, but I think just because there's 30 minutes to get on and then 5 minutes of a fun ride and then 30 minutes to get off. So, but I like, riding in them, the height of them, it's kind of fun. So what we're looking at here is, let's say that you're riding a Ferris wheel and you want to know how high you are above the ground at any point of the Ferris wheel stopping. So if you notice, this could rotate around, and right now J is at the bottom, but it could rotate around to any point on the Ferris wheel being at the bottom. Well, if J is at the bottom, how high off the ground are you at the other points? So that's what we're looking at here. We are going to find the height of all of the points from the ground, and the ground is from the Ferris wheel on up. So we're just going to list all those points. So let's start with the easy one. First off, you know that the radius of the wheel is 25 feet. So I'm just going to write 25 right here to remind myself that's the radius. All the spokes of this wheel are the same, so you don't have to, worry about them changing or anything. And then it says the center of the wheel is 30, and that should say 30 feet above the ground. So if the center is 30 feet, then how far off the ground are you when you are sitting on the Ferris wheel at point J? Okay, so there's the first question. Pause the video, think about it for a minute, and then turn it back on. So how you'd figure this is, if the center is 30 feet off the ground, 30 minus 25, at point J, you are 5 feet off the ground. So that one wasn't too bad, right? And also out here at A. So at A, how far above the ground are you? Well, you're the same height as the center. So at point A, you're 30 feet above the ground. And these are all feet. I'm not going to write those in right now. And also at G, how far are you? You are 30 feet also at G. Okay, let's do another fairly simple one, D. So if D is the 30 feet off the ground plus another 25, then how far up in the air are you if you are at point D, the very top? Well, 30 plus 25 is 55. So at point D, you are 55 feet above the ground. Okay, now let's get on with the challenging ones. So remember that there are 360 degrees in this circle. So what we need to do is find out how big are these inside, or these central angles right here. Well, if you notice, there's 1, 2, 3 in a 90-degree angle. So 90 divided by 3 evenly is 30. So these angles are all 30 degrees, right? So there are 12 of them, and 12 times 30 is 360. Now, this should look really familiar to you. It's kind of like the unit circle. So only this time our units for the radius is 25, not 1. So it's just a little bit different. But we still have a 30, 60, 90 triangle right here. So I'm going to look at this one first. I'm going to create my right triangle. It always helps me to draw it in because then I can visualize it better and it makes more sense to me. On this triangle right here, I know the hypotenuse is 25. And I want to find this distance right here because I know up to A is 30 feet. And then if I can find that distance there, I'm going to add it to A, and that will give me my height of B. So that's going to be my X. Okay, so I have a right triangle. I know one of the acute angles. I know the hypotenuse, but I don't know this leg, and this leg happens to be the opposite leg. So what trig function am I going to use that we have the acute angle, the hypotenuse, and the opposite leg? So we're going to use sine. So sine of 30 equals opposite, which is x, over 25. Now to solve for x, we're going to get the x alone, so we're going to multiply both sides by 25. So what that means, you're going to grab a calculator and go 25 times the sine of 30. And when you do that, you get 12.5. So x is 12.5. So that means that B is 12.5 feet higher than A. So that would be 42.5 or 42.5 feet off the ground. Now you also know that F is the same height. So F is how far? 42.5. That's a point right there. You also know that the distance from A going down to L is 12.5 feet less than 30. So how could you figure out how high L is? Yeah, we're going to take 30 and subtract 12.5. So 30 minus 12.5 is 17.5. So L is 17.5. And you also know what other point now? Yep, we know H is also 17.5. Okay, now we're going to look at C. And I'm going to draw my angle. I'm going to look at I over here. So I have some space to see what this angle is. So I'm going to go ahead and draw in the right triangle to help me find I. And I'm looking at this. And that's the radius of 25. And I don't know that value right there, but I can tell you what this angle right here is. It's 30 plus 30. So that angle is 60. I want to know this distance right here. So I'm going to call it y. I'm going to call it y just so we don't get goofed up with the x from over here. So what trig function am I going to use? For my angle, I'm looking for the opposite side and the hypotenuse. So I'm going to use sine again, only this time it's sine of 60 equals the opposite, which is y, over 25. And again, to solve for y, we're going to multiply both sides by 25. So you're going to grab a calculator and go sine, or 25 times the sine of 60 is 21.7. Let's round to the nearest tenth. So 21.7. So how to find this distance right here at I? I'm going to take 30 and subtract 21.7, and I get 8.3. 8.3 feet off the ground, which makes sense because this is only 5. It's just a little bit higher than 5 feet. We also know that K is 8.3. And we can use that same information to find E. E is going to be the same height as G, but then you add that 21.7 to it. So it is 51.7 feet. And C is also 51.7 feet. So these are all feet. I just haven't gone around and added all these in. So these are all in feet here. All right, now the second part of this down on the bottom, it says, now that you've found the height at each value, write a formula that could calculate your height at any point on the Ferris wheel given the angle of rotation. So if you noticed, what we did every time here, and we could have done it for the easy ones too. If we would have taken this sine of 0, we could have found that ratio. But let's look at the ones that we used. We did the sine of the angle of rotation, and it was equal to the opposite over 25. And 25 was a constant in all of the formulas because the hypotenuse was always 25. So take a second, think about that, and let's write what our equation would be. Well, our equation would look like this. F of theta. Theta is the angle of rotation. So that's our independent variable. Is 25 times the sine, oops, I gotta put a little s there, the sine of theta. And then what we did is we added 30 every time. And the cool thing about this formula is it works for every angle. Let's try it out. Let's try it at J right here. So the angle of rotation at J would be, you could do either a negative 90 or a positive 270. So if you take your calculator and you go 25 times the sine, I'm going to do negative 90, sine of negative 90, and then add the 30 for the center of the rotation, I get 5 as my height of J. Let's try it for E. So E, the angle of rotation from here all the way around to here, well, 30, 60, 90, 120. So our theta is 120. So I go 25 times the sine of 120. And you should grab a calculator and do this along with me. It's really kind of cool. 51.7. Awesome, right? Okay, now this is an assignment, and I am going to have you turn it in. I'll make an assignment page for you to upload and do it. But I want to just let you know, hang on to this assignment because we're going to look at it a little bit later because there's even some more interesting, cool stuff about it. So turn this in. I'm going to give you credit for working on it and figuring it all out. Good job. And just also hang on to it because we're going to use it later. Thank you very much.